Good morning to all. In this video, I am going to explain hydroxylation reaction and hydroboration reaction. Let us see about one by one. The first reaction is hydroxylation reaction. Hydroxylation reaction means addition of hydroxyl groups across the carbon-carbon double bond. There are two types. Number one is syn hydroxylation reaction. Another one, number two, anti-hydroxylation reaction. Syn hydroxylation reaction means addition of two hydroxyl groups added to the carbon-carbon double bond on same side. Anti-hydroxylation means addition of hydroxyl group on opposite side of the carbon-carbon double bond. So it depends upon the catalyst. Syn hydroxylation or anti-hydroxylation takes place. The catalyst used for syn hydroxylation reaction is KMnO4, potassium permanganate, and osmium tetroxide. These two catalysts mostly used for syn hydroxylation reaction. So the catalyst used for syn hydroxylation reactions are KMnO4 and osmium tetroxide. When alkene undergo hydroxylation reaction in presence of KMnO4 catalyst to form cis 1,2 diol product, and the mechanism is one step reaction which proceed through the cyclic manganese ester intermediate. So the product formed while using KMnO4 catalyst is cis 1,2 diol. Similarly, in presence of osmium tetroxide catalyst, the alkene form the same product cis 1,2 diol, and the reaction proceed through the cyclic osmate ester intermediate. So in both cases, using KMnO4 catalyst or osmium tetroxide catalyst, we get the product cis 1,2 diol, and the reaction preferably the hydroxyl group goes to less hindered side. For example 2 and 3 both are the example for cis hydroxylation reaction using osmium tetroxide catalyst or KMnO4 catalyst. The product is cis 1,2 diol. That means double bond gets hydroxylated and the hydroxyl group mostly substituted on less hindered sides. The next one is anti-hydroxylation reaction. Anti-hydroxylation means addition of hydroxyl group on opposite side of the carbon-carbon double bond. There are several catalysts used for anti-hydroxylation reaction. Number one is hydrogen peroxide catalyst. When alkene react with hydrogen peroxide, the trans hydroxylation takes place to form the product trans 1,2 diol. And in this reaction, the mechanism is operated by SN2 manner. That is, in the first step, the alkene react with hydrogen peroxide to form epoxide. Then this epoxide form trans 1,2 diol product through SN2 mechanism. SN2 mechanism means that nucleophile approaches the epoxide backside that of leaving group so that the anti-product obtained. So using hydrogen peroxide The major product is trans 1,2 diol. So anti hydroxylation is achieved by using the catalyst hydrogen peroxide. Another method for anti-hydroxylation by Prevost mechanism. In this Prevost mechanism, we are using iodine and silver benzoate in the ratio 1 is to 2. When alkene react with iodine and silver benzoate in the ratio 1 is to 2, we get the product trans 1,2 diol. That means anti-hydroxylation takes place. And in this reaction, the neighboring group mechanism takes place. The mechanism operated in this previous mechanism is NGP mechanism. That means neighboring group participation mechanism. Initially, in this reaction, when alkene react with iodine and silver benzoate to form the beta allobenzoate is the first step, and after this formation, the next benzoyl group is substituted by NGP mechanism. That means the benzoyl group present in beta allobenzoate act as the internal nucleophile will approaches the carbon backside that of iodine. As a result of this, that iodine leaves and the incoming benzoyl group act as the external nucleophile which attack the carbon atom where the iodine is originally attached. So that anti anti-hydroxylation product obtained trans 1,2 diol product obtained. So the anti-hydroxylation is achieved by Prevost mechanism. The next one is anti-hydroxylation, but in this reaction, Woodward modification reaction, we are using iodine and silver acetate in the ratio 1 is to 1. When alkene react with iodine and silver acetate in the ratio 1 is to 1, we get the product is cis 1, 2 diol. Cis 1, 2 diol. This reaction is called as Woodward modification reaction. In this Woodward modification reaction, the SN2 mechanism is operated. That means in the first step, the iodine and silver acetate is added across the carbon-carbon double bond and anti-addition takes place. Then followed by SN2 mechanism to form cis 1,2 diol. So the product in this Woodward modification is cis 1,2 diol. But in this reaction, the first step of this mechanism, anti-addition takes place. Anti-addition takes place, but we get the cis product, cis 1,2 diol product. So the hydroxylation reactions takes place under the influence of KMNO4 catalyst or osmium tetroxide catalyst. The major product is cis product. And similarly, when hydroxylation reaction achieved under the influence of hydrogen peroxide or Prevost mechanism, trans 1,2 diol product is the major product. Right. Next one is hydroboration reaction. Hydroboration reaction means addition of BH3 across the carbon-carbon double bond is called as hydroboration reaction. When alkene react with BH3, trialkyl borane product obtained. This reaction is called as hydroboration reaction. This is a mechanism of hydroboration reaction, and the mechanism is Markovnikov follows Markovnikov rule. That is, in this reaction, the BH2. In BH3, BH2 is electrophilic portion, H minus is nucleophilic portion. So the electrophilic portion is added to carbon atom of the carbon carbon double bond contain more number hydrogen atom. So this is according to Markovnikov rule. So that the product is um, trialkyl boron product. Addition takes place according to Markovnikov rule. In this first reaction, the BH2 is the electrophilic portion. That electrophilic portion is added to the carbon atom of the carbon carbon double bond contain more number hydrogen atom. That means the reaction is follows through Markovnikov rule. So the 98 percentage product in the first reaction, 98 percentage of the product is Markovnikov products. Let us see the another example. In this reaction, the second one, when alkene react with the BH3 to form equal amount of products because each carbon contain equal number hydrogens, so that 43% one product, 56% another product, both are, yeah, obtained in equal amounts because here each carbon contain equal number hydrogen, so that you get the equal amount products. And this reaction is hydroboration oxidation reaction. That is when alkene react with diborane in presence of hydrogen peroxide catalyst. The initial product is alkyl borane, which then treated with hydrogen peroxide, it gives alcohol. When alkene react with uh, diborane in presence of hydrogen peroxide catalyst, we get the product is alcohol, but that alcohol is anti-Markovnikov of alcohol. Whereas the same alkene treated with either acid catalyst um, or oxymercuration demercuration reaction, the product is Markovnikov of alcohol. Whereas the same alkene treated with diborane and hydrogen peroxide, when reaction using diborane and hydrogen peroxide, the reaction is called as hydroboration oxidation. When hydroboration oxidation carried out, we get the major product is anti-Markovnikov of alcohol. So in this reaction, when 2 methyl 2 butene form 2 methyl 2 butanol products. This product is formed through followed through Markovnikov rule, even though we get the anti-Markovnikov alcohol products. Is also hydroboration reaction. Alkene react with BH3, um, initial product or CH2, CH2, BH2, which then combine with further alkene to form trialkyl borane. So this is the mechanism operated in this hydroboration reaction. These are all the examples for some hydroboration oxidation reaction. When alkene in the first reaction, when alkene is treated with diborane in presence of hydrogen peroxide, as a result of this, the hydroxyl group hydroxylation addition of water takes place, and the alcohol, you get the product is alcohol, which is anti-Markovnikov of alcohol. Usually when alkene treated with diborane and hydrogen peroxide catalyst, we get the product is uh, alcohol product. And when using diborane and hydrogen peroxide catalyst, actually water addition takes place, and In this water addition, the product is alcohol, the alcohol is anti-mechanic of alcohol. So all the three reactions, number one, number two, number three, you get the same type of reaction. Addition of water takes place, and the alcohol is anti-mechanic of alcohol. Whereas the same alkene treated with acid catalyst, we get mechanic of alcohol. Thank you.